Alrighty, let's do it. All right, we're going to go live now. So, hi everybody, and welcome to QGIS Open Day. We are not coming to you on a Friday because, of course, tomorrow is Good Friday. In those of you who celebrate Easter, so happy Easter to everyone who does so. I'm very excited to open the first session. So we have the WAP plugin optimizing the FAO WaPOR data for land use and water productivity monitoring in QGIS. So I'm very excited to see this. You know, we've had some sessions about this in the past. I'd like to welcome Hans van der Kwast and his students. Hi, nice to see your comment in the live posts there. So please, if you have any questions, pop them right there in the live chat and I will post that over to the WAPlugin team. On that note, over to the WAPlugin team.
Thank you, Amy. Thank you so much for having us. And so my name is Zubeida, and I'm part of the WaPlugin team that developed the WaPlugin, which is a QGIS plugin that helps people download and retrieve WaPOR data. So for this session, I will start with a short presentation about WaPOR and also about the plugin, and then we will do a live demonstration on how to install the plugin, how to use it to download the data, and also some other cool stuff that we can do with the plugin itself. So I'm going to share my screen now. Yeah. Okay. So is it all right now? Okay, yes. Let me go to the presentation. Okay, so we titled this presentation Optimizing FAO WaPOR Data for Land and Water Productivity Monitoring in QGIS. And this plugin is developed by the WaPlugin team. And it is mainly focused on WaPOR data. So what is WaPOR data? So WaPOR data, or WaPOR, is the FAO portal to monitor water productivity through open access of remotely sense-derived data. So it was launched in June 2019, and this platform actually provides public access to available near real-time database of some data that are derived from satellite imagery. And these data are mainly used for agricultural water productivity monitoring, and it includes actual evapotranspiration, gross biomass water productivity, transpiration, and these are only some of the data sets available. You can find a lot of other data sets that we are going to see later on. And these data are available on or at 3 levels of varying resolutions. So the WaPOR dataset are available for 2 versions. We have the WaPOR version 2 and WaPOR version 3, and now we're going to discuss a bit of the differences that we can find between these 2 versions. So version 2 was launched in 2019, and the data in that version is available from 2009. The coverage is only for Africa and the Middle East, and it provides a data set at 3 levels: level 1 at 250 meters, level 2 at 100 meters, and level 3 at 3 meters. For the level 3, the data is only available for some project countries that we're going to see later on. On the other hand, the version 3 is quite recent, and the data has been available from 2023. And the data set that are available in this version starts from 2018. And what's cool about this data set is that it covers now the entire globe, so it went global, and you still have 3 data sets, 3 levels of resolution. The first one is global at 300 meters resolution. The second one at 100 meters resolution, only for Africa and Middle East. And the third one, which is level 3 at 20 meters for some project countries only. You can notice here that for level 3, it went from 30 meters to 20 meters. So to access this data, you can access this data using these links. So there is a platform for the version 2 and the new platform for version 3. The version 3 includes also version 2, so you can get WaPOR version 2 dataset directly from this platform, or you can use the version 3 to get access to both version 3 and version 2. So why use WaPOR? What is the benefit of such data set? So the most important thing is to improve agricultural planning. It's not limited to that, but since we are talking about agriculture and crop yields, and this was the aim of the FAO, to monitor crop water productivity and to see how land are producing yield and how the water is consumed our agricultural area. So what we can get out of these data when we use them is that we can, for example, optimize the irrigation schemes. We can also continuously monitor crops and their growth and also their yields. We can also use them to build some models, some predictive models to estimate future yields. This is about the productivity, the crop productivity. Regarding the second thing is that we can use it for environmental sustainability, and this one is really important because it has something to do with water, because as you know, for most crops we use water for their irrigation, so most crops are irrigated, and these water resources are really valuable. So every drop that we use needs to be efficiently used and needs to be used to produce and not just wasted. So with this kind of data, you can also improve the overall irrigation schemes over an area, and from that you can also limit the waste of water and use the right amount of water to grow the crops that you want, and you protect your resources. And it is not only limited to water resources but also to the soil itself, because the soil also needs to be sustainably used. So if you want to use it again, you need to protect the soil, you need to protect the water, you need to use them sustainably. And these FAO WaPOR data sets help you do that. So there are a lot of use cases where people around the world, or stakeholders, farmers, or people are using this data now. And these are some of the case studies that have been published, and you can find a whole bunch of these case studies in the FAO website. So you just need to go to the FAO website and look for WaPOR, and you have a list of all the studies and all the case studies that have been used, where WaPOR have been used. So now let's go to the fun part, so the WaPlugin. So WaPlugin is used to access WaPOR data in QGIS. And for now, I think there is a bit of a delay, isn't it, Amy?
Just slightly. It's fine, yeah.
Okay, good. Okay, so as I said, for now, to get access to these WaPOR dataset, you need to go through the platform. So once you get access to these datasets, you can use any GIS software, but our favorite, of course, is QGIS. So to get WaPOR dataset to QGIS, you need to go through the platform, which may be a bit complicated. So what WaPlugin offers is a bit of a bridge between these two. So between the WaPOR platform and the QGIS environment. So what it does actually do is help you download the data easily. So you get access to this list of WaPOR data that are available, and you select the one that you need, and then you download it, and it is there directly into QGIS, and you can use it for further analysis. Of course, we are going to demonstrate later on how to use it and how to download this data. So Plus, there is another thing that the WAP plugin can do is the productivity indicators. So there are some performance indicators. So these performance indicators use satellite images or data derived from satellite images to actually how can I say this, to assess how the irrigation scheme is it efficient, how the crop, what is the ratio between the crop and the water consumption, and so on. And all these metrics or these indicators help us say whether the scheme or the land or anything that we are growing is, if we are doing a good job. If not, then we need to change something in our plan, and we need to maybe change the irrigation scheme or change the crop that we are growing, or change or maybe do something with the soil or so on. So for now, we have a number of 6 indicators that are built inside the WAP plugin, and each one of them has a meaning, and each one of them helps you determine something. So there is a bunch of them here. So I have here an explanation of what these performance indicators means and how to interpret them. But we will be back to this one after when we are doing the live demonstration. So then we can compare and see what each one of these indicators mean. So now we go to QGIS.
Just before we head there, Jonathan Bartoli asks me to just add the links to the WaPOR site here. So perhaps if your colleague can pop them into the chat of this meeting, I'll put them over to the live chat.
Okay, she's going to do that. The link to WaPOR, please.
Thank you.
Okay. Good. Okay, so now we go to QGIS. So is it visible?
Yeah.
Can you see it?
Perfect.
Okay. So here I have my project here, and as you see, I have loaded a base map, a satellite base map, and I'm somewhere in Algeria, which is our home country. So I'm in northern Algeria, and I have a shapefile representing the irrigated area of the Metija Plain, which is one of the most important, let me say, it's the most important plain in Algeria in terms of agricultural production. So if I zoom in a bit here, you can see the extent of the agricultural activities in this area. So for us, like for Algerian, most of the food that we eat comes from this part of the country. So what we are going to do is that we're going to retrieve WaPOR data using this file or for this study area. So first of all, we need to download the plugin, the WaPOR plugin. So you go to Manage and Install Plugins. And okay, so let me do something. If I go here now and look for WaPOR plugin, it is not visible, but to find it, you need to click on Show Also Experimental Plugins, because the plugin is still experimental, and to get all the plugins that are experimental, you need to check this box here. And now if I look for the WaPOR plugin, I can see it here, and you can click on Install. Okay, cool. So it is done. You can find it here, or you can find it under plugin, WaPOR plugin, and then it comes here. Okay, so it's a bit slow, but it's not the plugin's problem. It's my computer problem. So don't get too. Yeah. So here it is. Okay. So we have the WaPOR plugin window here. So this one is the first one that pops up. To access the data, you need to sign in. So here it asks you to sign in using an API actually, and to get this API, you need to already have an account. So if you click here on account, it takes you to your profile on WaPOR version 2, of course. it takes you here and you have this message that pops up. So it says that this portal will no longer be maintained after December 2023. It's not a problem. So please refer to the new portal to find WaPOR data version 2 and version 3. This is what I talked about because they moved to another platform, to another portal. So you can find both of them there. But for us, we're going to be working on with this platform. So all the data is already stored in here. So we click on OK. If you don't have an account, you will be prompted to open an account or to log in if you already have an account. So here I am in my profile. So let me show you a bit how it is. Okay, so this is the base map, how the data is displayed on the portal. But for us, we are going to be retrieving this data into QGIS using WaPlugin. So I go back to my WaPOR, I go to my profile, and I look for the API token. So I generate a new one, copy it, and then go back to QGIS and paste it here, and then click on sign in. If I'm going too fast, just let me know so I can slow down.
No, great, yeah.
Okay, so once you have clicked on signed in and it verified that the API is actually linked to your profile, so it's okay. So then you have API token confirmed, access granted, and now you can use the plugin to download the data. So one fun thing you can do here to avoid doing that, going to the WaPOR portal and getting your API token, you can just click on save the token, and the next time you use the WaPlugin, you just need to click here, load the token, and you will have access to the WaPOR catalog. So here you have this window here where you have the WaPOR catalog. Here you have three parts that are important. The first one is raster download, the second one is coordinate selection, and the third one is the raster load. So each part needs some information that you will provide in order to choose or to select the raster that you need for your analysis. So the first thing is here you have the workspace. So the workspace means the layer that you are working with. So FAO has a lot of data sets that are available, and these are all the data sets that are available with the same API, if I may say. So you can try and select any one of these. You can also download the data using this plugin with other data set from here. But for now, we are just focusing on the WaPOR 2 data sets. And then the second thing you need to do is to choose the level filter. Level filter means that you have to select if you are working on level 1, if you're working on level 2, and if you're working on level 3. So you remember that we have three levels. Level 3 in WaPOR 2 is at 250 meters, level 2 is at 100 meters, and level 3 at 13 meters. Okay, so after you select the level, you can select the time filter, because the data that is available on WaPOR can be data on annual basis, decadal, long-term, monthly, or seasonal. So once you have selected the level, you can choose the time filter. Maybe we can select annual, and if you go here, you have all the rasters or all the layers that produce level 1 data on annual basis. So here you have a total biomass production, reference, evapotranspiration, and precipitation. Or you can just not select the time filter, and if you click here, you have all the data set that are available for level 1. So it's up to you. If you select level 2, also you have other data sets. So it's not the same. The data set change from one level to another. Some are the same, some are not. And for level 3, here you get another option, which is the country filter, because as I told you, the level 3 data are only available for some parts of, for some countries and for small areas. So if you want to use this data, you need to select one of these countries. So for now, level 3 is available in Egypt, Ethiopia, Iraq, and so on. So all these countries here have data for level 3 at 13 at 30 meters resolution. Okay, so let's go back to level 2. And here you have all this list of the data set. What is important is that when you select a raster, when you select a layer, you have to click here on the, I mean, you don't have to, but it is advised to, especially if you don't know, if you're not familiar with this, with WaPOR data set, because if you click on details, you get all these information about the data set that you are downloading. And of course, when you are using any data set, you need to be aware of what. Sorry.
Oh no, I was just thinking of attribution, etc.
Okay. Okay, so if we are using any data set, I think if we use it for any analysis or anything, you need to understand the data. You need to really understand what you are working with, which is, I mean, for me, if I don't understand my data, I am not using it. If I don't really understand it, like what does it mean, especially when it comes to remote sensing data. So here you have a really cool description of these data and the unit, the format and everything. But what is most important here, and something that you can maybe miss if you don't click on details, it's this one. So conversion factor. So for some data on WaPOR, you need to multiply the rasters or multiply the data set that you are downloading with 0.1 or any conversion factor in order to have the data in its real or in its correct format. If you don't do that and you use it for any further analysis, it's going to be wrong. So you just need to have all these description of your data set and read it and see what it means and how you can use it properly. Okay, so once this one is done, and you have here, like this is just a description of what this data set measures. So if I choose actual evapotranspiration and interception, what it measures is actually an amount of water. Let's see if I choose another one, maybe I don't know, transpiration. It's also an amount of water. Evaporation. It is also amount of water. Which ones? Yeah, let's see. Maybe this one. Yeah. No. Okay, so it's depend on the data set. So if you choose any other data set that doesn't correspond to the amount of water you have here, what it actually measures. Okay, so let's go back to the actual evapotranspiration. Now I have selected one that is annual, and you see here that I have not selected the time filter. I have just selected annual here, and it's automatically populated here the time interval. So what I'm going to be downloading further is going to be on an annual basis. And then I have this option here where I can download the rasters, like several rasters at the same time series. So instead of downloading each rasters one by one, which is really painful to do, especially if you have a large data set, and especially also if you are working on data that is on a monthly basis. If you're working on monthly data, you have all these rasters to download one by one, which is not really efficient. So to go fast, you can just select the first year you want to be working with and the last year. So if I select this, if I put it like that, 2021 and 2023, I will have 3 rasters, one for 2021, one 2022, and the last one for 2023. And let's just put in, and if I select this, if I put 2022 and 2022, I just get one raster, like for my area. And once I'm happy with all this, once I have selected the right raster layer, I have selected the right time interval and everything that goes with it, and also check the details to see if what I have downloaded needs to be corrected or not, I can go on to the coordinate selection, which is quite fun because you have two options actually. You can download the data based on the canvas extent, like the zoom of your canvas, like any extent that you need, or if you have already a shapefile, which most of us working with this kind of data have. So if you have already a study area and you need the data only crop to your study area, you can do that. You just select from shapefile, and then it gives you access to all the shapefile that are available on your project. In mine, I have 3 shapefiles, so I'm gonna choose the one that I'm gonna work with, which is the Mitija boundary, the third one. And then you need to tell the plugin where it's gonna download the data or store the data that is going to be downloaded. It creates a default folder, and you can change it. So you have already a layers folder that is created, but for me, I'm gonna change it and take it somewhere where I want to be working. And then I can just click on, before clicking on download, you need to name it. So this is actually cool too, because then you don't have to rename the data set, and you can just get easily the data that you want. So mine is going to be MET, which is Metija. And then here you have other indicators or codes. So level 2, L2, means the level 2, the one that we selected here. And AETI, which means actual evapotranspiration and interception, which is the layer that we have selected here, and A for annual, because we have selected an annual layer. And then you click on download, and you will get the data directly downloaded into your folder. So for now, I'm just gonna click on download and see what happens. Okay, so it is started downloading, and here it says that I have 1/1. If I have selected 22 to 23, I will have 2. So it will download 2 rasters, but my internet is a bit slow, so I would rather not try that now, but maybe we can try it later on. Okay, so the download is completed now, and if you don't want to actually go to the folder and get it into QGIS, you can do it directly into here to load it into your project. So you can click here, and you can go to the folder where you have downloaded the data, and you can click here, and you get all the rasters that are inside the folder, whether they are rasters that you have downloaded from the plugin or not. Like all the rasters that are available that exist in the folder will be shown here. So mine was MIT L2. So I will select mine, this one, the last one, and I will click on load in canvas. And the magic happens. You can see it here. So the data is downloaded quickly, and it is loaded to your project without even even going out of QGIS or anything. And if you go through the process with the platform, you would see why this is very fast and much more efficient than actually doing it the other way. So here's the data that we have, and here you can see the range of the data of the actual evapotranspiration and interception. And okay, so here you must think about something. If you want to use this raster as it is now to do something else, so the first thing you need to do is to actually multiply it by 0.1, because if you use it like this, it is not corrected and it's wrong. So you need to always check this and see if I need to correct this by multiplying it by a conversion factor, which is indicated here, it says that the pixel value in the downloaded data must be multiplied by 0.1. So if you want to take this elsewhere and use it for, I don't know, for a model or any other assessment that you are doing, you need to multiply by 0.1 to correct it. Otherwise, the result would be not correct. Okay, do you have any questions regarding the download part of the data?
Not from the live chat, other than this is awesome. The manual way is a little painful, so this makes life really easy. I love this.
Okay, good.
I might have it might be a sort of base level question. So why are we correcting it? And will it always be in that details, etc.? Is it just easier for the data to come through in that format? And that's why we're timesing it by 0.1?
Yeah, it has something to do with the coordinates, and so it is actually explained, not here, but in the platform. They explain this. It is not always by 0.1, so it has something to do with the conversion factors, means that you are going to convert into another coordinate system and so on.
Yeah. Okay, great. Yeah, that was it. You can continue.
Okay, so next to the WaPOR 2 catalog, you have here the WaPOR 3 catalog, which is not available yet because, as I told you, the platform changed, and the data structure and the data availability is not as simple as WaPOR 2, but we are working on it, and soon you will have also access to WaPOR 3. But the WaPOR 2, all the data from 2009 until 2023 is available here, and you can access it quickly and easily. What I would like to do before moving to the indicators calculator, I would like to explain a bit how to use it, but to download this time the level 3, because it's a bit different since these data are only available for some countries. So what we're going to do is that we are going to choose Egypt, but to download the data, you have to go to Egypt. You have to go somewhere. You have to, let me choose this one instead. Yeah, where is Egypt? Yeah, it's here, somewhere in here. So the data set that we are interested in are somewhere in here. We don't need to be exactly in that area or anything. You just need to be somewhere over the area. The canvas extent should include the area of your of interest. What we are going to do now is that we selected Egypt. And here you have a bunch of data that are available for this area here. And remember that these data are on 30-meter resolution. Okay, so let's select this one, for example, the actual evapotranspiration and interception, the annual one. You can click on details and you get all the data here. Here it says that the resolution is at 30 meters. And yeah, we can select year, maybe 2011 and 2012. Here it's gonna download two data sets, so two rasters, one for 2011 and one for 2012. For this part, you don't have to use from a shapefile, which makes sense because you don't have a shapefile for the study area, for this area. But we use the canvas extent, and when you use the canvas extent, what it does actually is that it downloads the whole area, the entire data set, which I told you is only a small area in Egypt. So let's name this, I don't know, let's make it Egypt maybe, yeah. And let's put the data in the same folder. So if I click on download, it is downloading now, and you can see it here, like downloading 1 out of 2. So we have two rasters, as I told you, because we selected 2 years, and it can go from 2009 until 2023. And if you want to use all of these data sets, you can just select here 29 and here 2023, and you get the whole data set in one click. It just may take a lot of time depending on your internet connection. Okay, so it is completed now. What you can do now is that you can look here and you have all the rasters. So I can see them here. I have Egypt level 3 actual evapotranspiration interception for 2012, and this one is for 2011. So I can, the same way, I can load these data into my project directly from here. So I can click on load in Canvas, and I can see the data here. If I zoom to layer, it is here, and as you can see, it downloaded the entire raster, and you can use them for any further analysis. So this is the only difference between downloading the level 1 and level 3, level 2 and the level 3, because level 3 you need to be actually on that country. So if I want to download data from Libya or from Lebanon, I need to go to Lebanon to actually download the data. Okay.
Brilliant stuff. We do have a couple of comments from the live chat. So Hans mentions that storing integers are smaller than floats. I expected it was to do with storage. Therefore, there's a conversion factor. He did mention that in WaPOR 3, there is going to be a tag in the TIFF file that will be interpreted by QGIS or your GIS software, and that will apply the conversion factor automatically, which is very useful for version 3. Then the next question is from Jonathan. Jonathan asks, are there any support channels or community forums available for users who encounter difficulties or have questions regarding the download and use of WaPOR data in QGIS? I'm assuming Jonathan is asking for any community forum that isn't the WAPlugin issue page. I have put a link to that in the live chat. So are there any community sort of channels available for people who are wanting to use the WaPOR data?
I don't know, maybe Hans can answer that, because at IHE they are taking care of this. So I think there are a lot of courses on IHE open courseware about WaPOR, and also on Hans van de Kwast open course GIS open courseware, where he explains a lot about the WaPOR and how to use them, and everything related to WaPOR. And forums that are available, I don't think so, but I think Hans can answer these questions in the chat.
Alrighty, we open the floor there, and again, Akshay did send the actual issue tracker, so that is also a good place to add any requests for features, or if you do encounter a bug, pop it into the issue tracker, and someone on the team will reply.
Yeah, anything related to a plugin, it's not a problem. We deal with that. We can help you. But when it comes to the WaPOR itself, I think, you can. There is also a way to report any issues directly to FAO WaPOR people, so they can answer you, and usually they answer, and usually they can help you with stuff. Yeah.
Brilliant stuff. Thank you.
Yeah. Okay, so that's for the download part. If you still have questions, we can go through them later on. So as I said, for WaPOR 3 catalog, it's going to be available soon. We're working on it, and you will have access to the WaPOR version 3 catalog very soon. And now let's move on to the indicators calculator. So for this part here, I think this is the most interesting part, because getting the data, it's quite easy. So as I said before, what we do is that we need to evaluate the crop and the land and the water productivity of a certain area. This is mainly used or done by data that we collect from, or what we call ground measurement. But as we all know, these data are not really available, and they are really scarce, and it costs a lot of money and a lot of time to get hold of these data. So what we do is that you have this, you have another option using data from satellite imagery. So these indicators that are proposed here are based on data that is extracted from WaPOR, and it is data from remote sensing, derived from remote sensing products. So as I said, we have a list of seven indicators. And these indicators, what the plugin does actually is that you need to download the data, you need to download the rasters. So if for example, I want to calculate this one, the first one, I want to have the equity. I need two rasters, or I need at least one of them. I need actual evapotranspiration and interception, and also potential evaporation, which is available on the WaPOR catalog. So you just need to look here and see what the plugin or what this indicator requires as an input, and you need to download it from the catalog as I showed you before, and then you will compute it directly. So we're gonna try to do this. So for the equity part, what we need is the actual evapotranspiration and interception. We're going to do that for the Mitija plane. So for the first data set that we had, let me just remove this one and go back to our study area. So if I go back here, I have this option here. Okay, so I need the actual evapotranspiration and interception. The folder rasters, this means that it requires you to go to the folder where you have actually downloaded and stored your data, your WaPOR data. So it automatically syncs with what you put during the WaPOR catalog download. So if I select another one here, it automatically selects here. And what's fun here is that these inputs are automatically populated because we wanted to reduce the errors. So here what it requires is actual evapotranspiration and interception. And if I click here, what it gives me is all the layers that are available in my folder and represent the actual evapotranspiration and interception. What you need to do is just to select the right one based on the year you want to work with and the area you want to work with. So here it gives me all the data set, all the rasters that represent actual evapotranspiration and interception. If I had any data about the potential evapotranspiration, I can have it stored here and I can see it here and select it too. But for now, I just have the actual evapotranspiration and interception. But to understand what we actually are computing, we need to understand what equity means when it comes to WaPOR data, or when it comes to performance indicators. So if I go back to the presentation, I have here some definitions on some of these indicators. So the equity measures the evenness of water consumption between fields within an irrigation scheme with an homogeneous crop. So it's sort of the uniformity of water. How is water consumed between these fields? And it is actually a percentage. So if you have values between 0 to 10%, we can say that we have a good equity. If it's from 10 to 25, it's a fair equity. If it's above 25, it's of poor equity. So we're gonna compute this indicator for our study area and see if it's poor or fair or good. So here I have, I need to select the right one, which is, as you remember, this one, the Mitija level 2 actual evapotranspiration and interception for the year 2022. And if I click on calculate, I get this value here. So I have an output value because this for this parameter, for this indicator, it is not, the result is just a percentage. So it's calculated for the entire area. And here I get a value of 35, and it is just, so you know, we usually calculate these indicators for small farms, for small areas where we have other data set that we need to include too. So if I ask you a question now, what do you think about this value here? Are we in good equity, fair, or not, or poor one? So it's 35. If I go back to my presentation, I can see that what do you think? It is poor, fair, or good? This question is for you, Amy. Are you following?
Well, I'm going to go with it's poor because it's above 35, which is above 25.
Exactly. So, okay. So now, 1 point for you. Yeah. I hope Hans students are following too, and they did good answering the question. Okay. So the value here is 35. You can do this for other areas. You can maybe get. Okay, I forgot to tell you something here. So as you noticed, I have directly chosen the raster that I have downloaded previously, which means I have not corrected the raster, which is not necessary when calculating indicators using data set that you collected from WaPOR, from the WaPlugin, because the conversion factor is already included inside. We did this because we were afraid people will not will forget to use the factor to actually correct the data. So it is directly, you don't need to select the one that you corrected. You just download and go to the indicator calculator and calculate your metrics without having to actually go through the correction. The correction is only needed if you want to use it for another thing besides the WAP plugin, like, I don't know, like use the raster calculator for to calculate some statistical parameters. So for that, you need to use the conversion factor. But here, you don't have to do it because it's already corrected. So
in the
now,
live chat, Jamal Mohammed says poor, and apparently the whole class guessed poor, so that everyone got it right.
Perfect. Good. Okay, let's move on to the next one, which is the beneficial fraction. Okay, so for the beneficial fraction, what we need here is we need the actual evapotranspiration and interception and the transpiration. So you need two rasters. So it's actually the ratio between the actual evapotranspiration and the transpiration. And as you see here, it is automatically populated, but you need to select the right layer. So like, for example, here I have these four rasters. The one I am using is the Metija level 2 actual evapotranspiration and interception. But if I click on transpiration, I don't have the data set that corresponds to the same area, but to the transpiration. So what I need to do is that I go here and look for the transpiration layer that will be downloaded for the same year and for the same study area. So I will do that now, transpiration. Select the same year, 2022, and name it also MIT, not MIT, but our Metija, not what? Massachusetts Institute of Technology, right?
That's the one.
Yeah. Okay, so we click on download and we wait. Hopefully it's gonna be fast. Okay, we can go to here and read a bit about this beneficial fraction, what it means. So what it means is the portion of the water that is effectively used by crops and contribute to their growth compared to the total amount of water applied. So it is something that we use to evaluate the effectiveness of the irrigation scheme or irrigation system that delivers water to your plant. So the actual evapotranspiration and interception measures both the transpiration, measures both the evapotranspiration from the soil and also from the plants. And the transpiration measures only the water that is produced by the plant. So when you calculate the ratio, you can get values and depending on those values, you have the ability to say whether all the water that is being given to the plant are used for production or not. So like if the water I am providing to my farm is not enough, or if it's over irrigated, meaning that I have given more water than the crop actually needs, and if it's stable, meaning that all the water that I gave produced crop or have been used by the plant. Okay, so the layer is downloaded here. Let me see. Yeah, it's here. It's MIT L2 transpiration. And we can go to the indicator calculators, and you can see it now here. So I select it, and this one I select for the same area. And you need to be careful here when you are using, or when you have a lot of data set or rasters in your folder. You need to be really careful, because it happened to me a lot of time where I select different data set, and it will get confusing.
Human
So
error.
just make sure. Because it actually does the calculation. It doesn't care, especially if you are working in the same areas with small small shapefiles and stuff. So you have to be careful about that. So what's important here is that the resolution doesn't really matter. Like, of course, we cannot get all the required rasters at the same resolution. Sometimes it's just not possible. Here we are lucky because the actual evapotranspiration and also the transpiration are available for the same resolution, meaning up to 100%, because we're using WaPOR 2. But and level 2, but sometimes you have some indicators that require other data set. We're going to see it later on, but these data sets are not are not available for the same resolution. So it doesn't matter the resolution. It still works, but it would have been better if we had the same resolution. But what you have to be careful about is about the time frame. Like if you are like computing these indicators for annual data, both data that you are using need to be annual. It doesn't make sense to calculate the beneficial fraction for the annual and monthly data or deviated data. So I don't know if it makes sense, but yeah, this is how it should be. And
a note from Akshay. He said that for the transpiration, it should be the same shapefile as for the evapotranspiration. I think you may have gone for canvas extent just because of the previous setting.
Yeah. Sorry?
Oh, sorry. Just Akshay said we need to use the same shapefile for both of those layers, the A, E, T, I, and the T.
Yeah. Okay, so the output of this indicator is not as the equity one. So the output of this one is actually a raster. It's a TIFF file. So you need to give it a name. Let's name it BF MIT and give it for 2022. And just hit on calculate indicators, and you have it here. Okay, so we have it here, and for now it doesn't sample anything, so let's just make it prettier. Yeah, we can use the quantal one. Yeah, so here you go. You have it. You have your values. You have your beneficial fraction calculated for the entire area. And again, I'm saying that these indicators are usually really calculated for small area where you have you have more information about your area, and also the better the resolution, the better the outcome. This is just to show you how it is done. And as you can see, the values range from 1 to 240, which is huge, meaning that there are some areas that are over irrigated and others that are not. But this doesn't really make sense, because inside this area you can find I don't know, water basins, and you can find some populated area, which can give you a bit of, which can be a bit, like it can produce values that are not, that doesn't make sense. Okay, the same way goes for adequacy. So for adequacy, what you need is you need the two layers too. You need the actual evapotranspiration and interception, and the reference evapotranspiration, which are two layers that are available for the WaPOR2 catalog. And then you have this one here is KC, which means a constant to compute potential evapotranspiration. So for the adequacy, it has something to do with the type of crops that are being grown in your study area. So if we take it for this entire area, of course, it is not the same crop. During the year, we have various crops and various types of yield. So it is necessary to have this information because of this value here that you need to put in here. So you need to add this KC value in order to compute the adequacy. But I'm going to just show you how to do it. It's the same way as for the beneficial fraction, and you can calculate it and get the information. So for you guys, if you have, I don't know, a small farm where you have information about the crops, maybe wheat, maybe, I don't know, vegetables, because there are some information and there are some metrics about this, like there are some values that you need to indicate here for each type of crop. So if you have, for example, a farm where you know that in this farm you are growing wheat, you can add the values that goes with wheat in here. I don't have the values in my mind, but yeah, you can look for them and introduce them in here. So let's just see what adequacy means. So the adequacy actually is the measure of the degree of agreement between the actual water use and the crop water requirement. It just means that if we are given enough water to our crops. So if we are given, I don't know, if the values are between 0.8 and 1, the adequacy is good. If it's from 0.6 to 0.8, it's acceptable. If it's less than 0.68, then it's poor. And yeah, all these can be found in the literature, so you can follow. And we're gonna share with you some of the literature where all these indicators have been presented and how to actually interpret them and give them sense, or actually use them to take decisions regarding a certain area. So as we can see here, we have the actual evapotranspiration and the RET.
Just a note there, we are running a little bit towards the end of the time of this session. I can allow us to run about 5 minutes or so over, but just so you know, we're sort of close to that final end bit.
Okay, then yeah, it's not a problem at all. Then I think we can stop here.
Yeah, so if you have anything that you want to finalize with or show us specifically, then let us know, but we can run a little over.
I think it's quite easy and direct how to actually use these indicators. And you have the 7 one, all the remaining 6, the outcome is, the output is a TIFF file, meaning it's a raster. So you just need to read here what the raster means and the indicator means and what type of data it requires. And yeah, and try, and you can try for different areas and compare between them. And you can afterward, what is interesting is that based on these data, you can take real decisions. So this makes things easier and faster, and people can focus on actually taking decisions based on the result than actually getting to the data, which is like get the data and compute the performance metrics and so on. So I'm just gonna show you what we maybe I can share with them the presentation later on, and yeah, they can have we can have access to the presentation and also see the different performance metrics and what they mean. So what we are working on, and hopefully the next time we meet, we'll be talking about these, is the access to version 3, as I told you before. So the next thing is that we are going to link the WAPlugin to WaPOR version 3, so you can get the newest data and also time series. The second part, which is quite interesting and also my favorite, is the WaPOR data validation. So as you know, all the data that is produced using satellite imagery needs to be validated using ground measurements. So these data are available, but you need to assess their accuracy so you can use them to calculate the metrics. So actually what we have been doing now is kind of wrong, because we have been using the rasters as they we assumed that the data that WaPOR gave us is correct. We did not validate it, or we did not compare it to ground measurements to see if it's actually correct or not. Because as you know, remote sensing data can have a lot of factors that can make the data wrong or not good enough. So we need to assess this. And to do that, it takes a long time too, and it's quite complicated. But what we are working on now is to integrate this validation. So you can see this as you download the data, you validate with your own ground data, and then you use them to calculate accurate indicators and take decisions afterward. And regarding the indicators, we are going to add a list of other indicators, and maybe if you have your own indicators, you can use them in the plugin, introduce them, and use your own formulas to calculate the indicators that you wish to calculate. And you can contact us on LinkedIn or on Twitter, by Gmail, or on GitHub. So that was all for me. I hope it was not too much. If you have any questions, contact us. We will be really happy to help. And also, you can help too by providing us with your ideas and also suggestions. And if you want us to improve anything, or if you have anything specific in mind, just let us know and we can work on it. And thanks.
Brilliant stuff. Thank you so much, Sobida. This was really fascinating. And I really like, the implications of being able to use these different indicators, to assess. I mean, even at a small level, at a single farmer level, they can use this to really, inform their decision-making for crops, for water usage, for selecting the correct irrigation methods. So I can see on both a small and a large national level, even being able to use this data and being able to use those indicators. That is fantastic functionality. And I think, moving forward and allowing people to use their own indicators and algorithms, for want of a better word, perhaps I should say calculations there, would be really, really useful. So thank you. This is absolutely amazing. If there are any last questions, we have about 3 minutes for anyone in the live chat. So please pop a question there if you have. And anyone in the room who would like to ask a question, please feel free to do so now.
In the meanwhile, I would like to thank Hans for his support during all this time. Yeah, he's really like our superhero behind us, pushing us and making things happen for us. Yeah. And hi, Akshay.
Brilliant stuff. All right, so thank you everyone for joining in to this session. The next session will be in about an hour or so, so please take off some time. I'm going to grab some tea. Thank you for everyone who joined in and interacted. All of the information, of course, has been added to the live chat as we've been talking about it. Thanks a lot. Hans pops in and says, thanks a lot, Subida and team. And thank you for the class, for tuning in. And thank you to everyone else who tuned in and interacted with this really great session.
Yeah, and QGIS is the best, right, Amy?
Oh, definitely. 100% agree. Brilliant stuff. Thanks, everyone. I'll see you in the next session.